Right, here another similar kind of question here. A student investigate the acceleration of a trolley. Diagram below shows how the student set up the apparatus. So he has a wooden block and they have an inclined plane elevated. So they also have a mass holder, trolley cart, and a string attached to the trolley cart. So light gate, they have a light gate and data locate to calculate the velocity and acceleration. So before attaching the mass holder, the student placed the trolley at the top of the runway. The trolley rolled down the runway without being pushed. So without any push, it just rolled down. What change the apparatus in the diagram would be made to prevent the trolley from rolling down the runway? So what can we do? So if we move the wooden block to the left, it will make it the slope make the slope shallower, like the gradient will be shallower, so it will reduce it. Or shorten the length of runway. If they shorten the runway, it is not going to help, is it? Use the taller wooden block. So if you use the taller wooden block, it will be more elevated, so that it will roll down faster. So the first one, so you could move to the left so that the elevation is going to be smaller, and then it's going to roll down slower. The student attached the mass holder to the string. So mass holder is here, and then they are attaching it to the string, and string rubbed against the edge of the bench as the mass holder fell to the floor. So they didn't use a pulley here, so that edge is going to be rubbed, so there's going to be a friction. Suggest what the student could do to prevent the string from rubbing. So they could use a pulley system. Okay, so they could use a pulley. The light gate and the data logger were used to determine the acceleration of the trolley. Student increased the resultant force on the trolley and recorded the acceleration of the trolley. See here, they have increased our force by 0.05% every time, and the acceleration 0.09, and so 0.07, 0.07, 0.09. So every time they increase by 0.05 Newton, the acceleration is not linearly increasing, but it's increasing. So graph below is an incomplete graph of the result, acceleration and resultant force. So resultant force, you can use, let's say, 5, 10, 20, 25, 5, 10, 15, 20, 25. Right, let's see that. We use that then 0.05, 0.010, 0.15, 0.20, 0.25. Okay, for 0.05, 0.8, that is going to be here. 0.18 is here. 0.25 is going to be here. And 0.32 is going to be here. And 0.41 is going to be here. So more or less, the best fit line has to go through the most of the points. So if we draw a graph like this, you should get a marks. Describe the relationship between resultant force on the trolley and the acceleration of the trolley. So it is directly proportional. It's because a straight line through the origin. So directly proportional. As the best fit line is a straight line through origin. Okay, so describe how the investigation could be improved to reduce the effect of random error. So random error, we can do repeats in order to reduce the random error. What they can do, they can reduce, they can repeat, find anomaly, and find a mean. And you need to say avoid anomaly in the mean calculation, or identify anomaly and disregard the anomaly. Okay, so in this particular one, what they can do in order to use the, I think that's what they can do, and describe how the investigation could be improved to reduce the random error. So they can repeat the acceleration reading for each net force, maybe 3 times. Identify and discard the anomalous result, and find the mean. Okay, write down the equation that links acceleration A, mass M, resultant force F. So that is based on Newton's second law. F is equal to M times A. So net force is directly proportional to acceleration, and mass is inversely proportional to acceleration. So F is equal to MA. Resultant force of a trolley, the F is equal to 0.375 Newton. Mass is equal to 0.60 kilogram. And you need to give your answer to 2 significant figures. You need to calculate the acceleration. So acceleration is equal to F divided by M. That F is 0.375 Newton divided by 0.60 kilogram. And that should give you 0.375 divided by 0.60. So that should give you 0.625, but for to your 2 significant figure, that should give you 0.63.